This week we're going to try to wrap up Chapter 27's bookwork slides and then move into our non-test cumulative project. But first we have to work on slide 4 today. So we can do classwork or go in the stream to find the book questions for Chapter 27. Press the up arrow, the yellow slides with your name on it, and of course, the squareo. Now that we're in, we can split screen with the book, or I suppose you could use your actual book if you prefer. It's no big deal. We go to slide 4 today. And so I'm going to X here down. The top red document is the book. I'm going to go find section 2. Now our notes that we took were a little bit about section 2. So when we look at how your eyes and mouth are defended, your eyes and mouth are defended in a very similar way, the same thing. But your nose is defended differently from your eyes and mouth. Then we have your skin. Question 12 is in the paragraph about skin. And it actually helps you 3 ways, but you just need 2 answers. However, when you get a cut in your skin, the barrier that protects you on the outside is damaged, we need to figure out what your platelets do. And so your platelets, their job is to stop that damage. Now I'm looking for platelets. I'm pretty sure they're on this page. Yep, it looks like they're on this page. Yep, there it is. Okay, sorry for that delay. So the platelets are on the top there. The immune response and where your immune system is found, the second part of question 13 is also on that part. And so we need to look at the immune response. Now we already talked about the cells for your notes. Way back in slide 2, your notes talked about the role of the macrophage, the helper T, the killer T, and the B cells. And so that's what all this was about. The macrophage, its job is to eat pathogens, which it does. And when it finds one, it displays pieces of them called antigens. Helper T cells realize there's a problem, and helper T cells wake up the killer T cells, whose job it is to kill your infected body cells before they burst and spread more viruses, and the B cells, whose job it is to make antibodies. The antibodies stick to the pathogens. When the pathogens are all gummed up with these Y-shaped proteins, then they can't infect cells anymore. And then at the end, the macrophage helps out by cleaning up and eating all the deceased pathogens. So that was what you were supposed to look for in your notes. And that's what happens with the cellular response. Now, a fever is another portion of this. When you get a fever, that's not the pathogen, that's your body. And a fever helps you in 2 important ways. Now, this is a low fever. A high fever, up above 104 degrees Fahrenheit, or 105, is dangerous. So you need to read about that as well. Now, when we fight off a pathogen, the first couple days we're infected, we often don't feel sick. But it can take up to 2 weeks to successfully fight off a pathogen, and that's here. And if you get infected by that same pathogen again, it can only take 3 days instead of 2 weeks. So that's 11 days faster. And there's an important reason why. Often in those first 3 days of your second infection, you don't feel sick. So we're actually constantly fighting off infections, but because we've seen them before, we never feel sick. So someone who had COVID was infected. If they get reinfected, it's in them again, but because their body knows the pathogen, they can fight it far more quickly and actually probably never feel sick. Now, the other thing we're going to be doing is looking at disease projects. We're going to have a GIM kit for, proving that you know the material, playing GIM kit to a certain money value. We're getting better at that. But instead of a test, we're going to research a disease. So your choices are anthrax, babesiosis, bubonic plague, also known as the Black Death, Chagas disease, cholera, chronic wasting disease, which is mostly a disease of deer, but it can cross over into people, dengue fever, Ebola, E. coli, Giardia, Hansen's disease, also known as leprosy, hantavirus, HIV, which causes AIDS, influenza, which is the flu, Lyme disease, mad cow disease, very similar to chronic wasting, MRSA, which is methicillin-resistant Staphylococcus aureus, so you should be glad, MERS, which is related to COVID, measles, mononucleosis, mono, polio, rabies, Rift Valley fever, Rocky Mountain spotted fever, salmonella, SARS, another COVID relative, scarlet fever, smallpox, we talked about that at the beginning of the chapter, tetanus, tuberculosis, that's what our movie was on, typhoid fever, West Nile virus, yellow fever, I believe you read about in English class, and Zika virus. So you are going to pick one and research it on your own, like most research. You're going to have some required topics, but you're also going to have some freedom to just find some facts that you're going to find, and we're going to present to each other. So we're either going to actually do a presentation on slides, or we're going to make a video to play for the class that will be narrated. So that's where we're headed with disease research, and that will wrap up our chapter 27, and then we'll leave this behind and we'll go back in to chapter 18 and start talking about big ideas and environmental connections. All right, I can't wait to get started. I'll see you when I see you.